Hi everyone, my name is Annika and I'm part of the data science discovery staff, and today we're going to be doing a problem on experimental design. So let's go ahead and get started. So it says here elevated cholesterol levels represent a significant health concern worldwide, right? Often linked to increased risk of cardiovascular diseases. And then seeking these interventions, these researchers took an investigation to really assess these cholesterol lowering effects of a tea extract. So I know this is a lot of text here, so something that I like doing is, highlighting the really important information that helps me decide, what we're dealing with, which type of experiment this is, and important factors that may tell us if, there's bias or randomization included in our study or not. So it says here to rigorously evaluate its impact, the study employed a randomized controlled trial design. So this one kind of tells you right away, right, what type of experimental design this is, incorporating both treatment and control groups. So conducted in these, clinics, the trial enrolled 240 individuals, each exhibiting these sort of, um, health characteristics and adhering to a low-fat diet. Right, so the intervention involved administering a daily capsule containing the sort of green tea extract, while an identical placebo was provided to the control group. So neither the healthcare professional nor the patient had any knowledge if a placebo was being used. Now it says here the outcomes of interest included the mean percentage changes in total cholesterol and LDL-C, HDL-C, and these triglyceride levels. After 12 weeks, participants in the tea extract group showed notable improvements in their lipid profiles, and they kind of expand this more here. And in contrast, the placebo group did not experience significant alterations in their lipid levels. And then these results also demonstrated that this tea extract efficiently or effectively served as an kind of like a substitute to a low saturated fat diet. So right away here, we can see that the study type we're dealing with is a randomized controlled trial design, right? And how do we know it's an experiment? Well, first of all, in an observational study, you're kind of just observing the subjects that are involved, right? The researchers don't really have any, power over which groups subjects belong in. And in an experiment, we can kind of choose different methods such as random assignment or things like that to really control, which groups subjects belong to. So this is clearly an example of an experiment here, since we have both treatment and control groups, and that control group had the placebo while the treatment had this, basically this tea extract, right? So here we can see that the study type is a controlled experiment, and more specifically, it's a randomized controlled trial design. So randomized controlled trial design, because again, there was, probably random assignment involved, and there's that control group. And now, do we think there's a placebo? Well, it says here that an identical placebo was provided to the control group. So it kind of says in the question that there was a control group that received a placebo. So we would say that yes, there's a placebo. And is it double blind? Well, it says here, neither the healthcare professional nor the patient had any knowledge if a placebo was being used. So, for example, the doctors who were, kind of studying on these patients, and the patients, none of them had any knowledge of basically what pill they were taking. Is it the actual green tea extract, or is it the placebo? So neither of these groups know which, group that subject belongs in. And they don't know what sort of treatment or placebo they're even taking. So because of this, this actually is a double-blind experiment, because we see here that nobody knows, which group the subject belongs to. if only the healthcare professional knew which group the patient belonged to, aka like what pill they were taking, if it's a placebo or that tea extract, but the patient didn't know, then that's single blind. But here, none of these groups know. So we can safely say that yes, it is a double blind experiment. And can we trust these results? Well, since this is a randomized control trial design, that is a ideal experimental design to avoid bias in our study and to really trust the results and know that, since there was random assignment involved, and even here, since it's double blind, so it reduces bias further, there's less chance of confounding variables really affecting those results of whether the treatment effect was actually useful in lowering these lipid levels, right? So here we can say that first we can say that yes, we can trust these results because this is an RCT, right? It's a controlled experiment. It's a randomized controlled trial, right? This means that we can really trust the results. Now, we can't just say that because this was, an experiment, that doesn't mean we can trust the results, right? For example, if we have these two groups, if we have this control group as well as this experimental or treatment group, that important factor is really, if you have that whole sample, deciding who to place in what group. Since the randomization was involved here, that would reduce bias because there's an equal chance essentially of a subject belonging in the control or experimental group. We are deciding based on random assignment whether these subjects belong in which single group. If randomization was not used, then maybe researchers could place all the healthy people in the experimental group and some of the not so healthy people in the control group and say that, oh, the treatment was effective because clearly the experimental group contains a lot more healthier people with lower, these lower lipid levels. But that's not really true, right? That happened because a lot of the healthier people were in that experimental group. But here, since this randomization is involved, we know that these lower lipid levels are only due to the actual treatment, only due to this, green tea extract, and not other confounding variables such as, a lot more healthier people were in that experimental group. So if that makes sense, because this is an RCT, because this is a controlled experiment with that ideal design, that really reduces that bias and effect of confounders, we can trust these experimental results. So I hope this was helpful. If you have any questions, please let me know, and I hope you have a good day. Bye.